Hi and welcome. My name is Andrey Devyatkin, and today we're going to be talking about HashiCorp Vault and how you can deploy it using HashiCorp Terraform. I'm going to share experience that I had with HashiCorp Vault during the last couple of years while deploying that to different organizations. There are games that you can play with kids, like this one, where you teaching them how to spot differences. And it might be quite fun, though it is not so fun to play this game on your production servers, especially when there is an outage going on and you're trying to figure out what's the difference between those three servers, or if you suspect that there is intrusion going on, and there you really want to be sure that, well, whatever is there is intended to be this way, and you want to find all those differences very quickly. So, as I said, my name is Andrey. I am a technology specialist focusing on cloud deployments, infrastructure automation, continuous delivery. I have more than 10 years in the industry. I'm a consultant and co-founder of 5XL. I have plenty of certifications, which is not very relevant for today, and I'm organizing meetups and conferences. I also recording podcasts with Julian and Matthias. It's called DevOps Talks. Tune in if you would like to hear more from me. I time to time do public speaking like today, and I quite often do training sessions like Docker, Jenkins, Console, Kubernetes, continuous delivery, and many other tools. So why this presentation and what to expect? I'm not in any way pretending to be an expert. I'm just practitioners like you. I'm just practitioner like you, and I'm sharing what worked and what didn't for me and hope it will be useful. So going to be technical details and references, though you don't really need to screenshot them because we're going to be a recording, and also all the slides, they will be available. So Terraform, it's a tool that is quite often being used to implement infrastructure as code that allows you to describe everything you want in a more or less declarative way, and then have executions planned so you could plan out what's exactly going to happen. Terraform is smart enough to know dependencies between your resources that you're about to create, and then it can create them in a particular order thanks to resource graph. Also, Terraform is very useful to drive infrastructure automation and making sure that you're fighting configuration drift as efficient as possible. It has plenty of open source models. I think you have open source models for almost anything nowadays. You can configure Cisco routers, you can configure Pingdom, you can configure AWS, pretty much any major public cloud provider, plus automation for the stuff that you can have on a primary data center. And Vault is one of them. So we're going to be talking about how you use Terraform for Vault. And Vault is a solution from HashiCorp to centrally manage your secrets and reduce the secrets sprawl. By that, they and me, we mean that your secrets might be stored in all different places. If you want to rotate one of them, well, that might be a challenge. And also, if everyone has access to the same SSH key, you don't really know who is logging in into your servers. Vault allows you to shift from static credentials to short-time dynamically generated ones. So instead of using the same AWS key, you can get short-lived AWS keys, similar to how you would have it with the STS endpoint in AWS. Or for instance, you can generate dynamic database credentials, which is super handy. And on top of that, you have audit trail, so you actually know who accessed what, which is super handy when it comes to compliance requirements. It allows you to protect data across private data center and also on the public cloud. And you also have break glass procedure signs. You know where the things are. I mean, they stored in one place, so you have a possibility to just lock it down and don't allow anyone to get the secret. If you think that there is intrusion going on, or for instance, since you're getting dynamic credentials for everything, every workload gets its own version of the secret. It gets its own dynamically generated secret. So that means that if something being compromised, you could actually easily spot where the problem is and revoke only that credential, and the rest will work smoothly. Imagine if you're reusing the database password for everything. Everyone has a database password. Revoking that one would be quite painful, and you might cause a downtime. You can learn much more about Vault from this video. You just Google Introduction to HashiCorp Vault by Armon.com. Right here, you can see the name of the video, and Armon goes in great details about how Vault might be useful for your organization. So, assuming I convince you that you have to be using Vault, and hopefully your infrastructure is code adept as myself, so you want to use Terraform for that. So where do you start? You have to collect requirements and clarify the context first, and that will give you a lot of answers. So those are questions you can ask. How are you going to deploy? What capacity is available for you? Are you having access to the VM cluster, the VMs running in the cluster, or maybe like EC2s? You have maybe containers running somewhere already. Maybe you have a bare metal servers. How are you going to maintain this installation? Are you going to patch it, or will you do immutable infrastructure? So you build the image and redeploy every time you need to change. How are you going to access it? Like VPN, internal network, public, maybe something else, maybe some kind of hybrid. How to unseal, that's kind of important, because by default, Vault, when it boots up, it's sealed, so you cannot use it. You'd have to reconstruct the master key. And to do that, you have to introduce the keys it will generate when you initialize the Vault. But from 2008, HashiCorp open sourced a couple of auto-unseal methods. So for instance, you can use Cloud KMS to encrypt the master key, and then Vault will be able to use Vault KMS to decrypt master key, and then use master key to decrypt database. Or there is a transit unseal where you can have two Vault clusters unsealing each other. Then how do you get initial secrets in there? Like, for instance, how do you get TLS certificates deployed to your Vault installation so you can access it over HTTPS and terminate, Vault terminates HTTP TLS connection? How are you going to store Vault backend, the Vault database, what the storage options are available? How do you stream logs out? So you want to lock it down, right? So you want to get everything out, so no one needs to go there, never. And for that, you need to stream out logs, you need to stream out telemetry, you need to extract audit files, right? Are you going to do it multi-data center, or you just have one cluster? Will you have one Vault cluster per environment, or will you have one cluster for all environments? So those are relevant questions to ask. And there is no silver bullet, really. It's very dependent on what your environment is, what your development practices are. So think about those. And the good thing is that there are a lot of best practices available. There is a registry, Terraform registry, where you could find a model, Terraform model, that you can try to apply. It might not work for you. You might need to tweak it, but this is a great way to start. Also, Gruntwork offers the models. There are Helm charts to deploy to Kubernetes. And also, there is a terrific resource, learn.hashicorp.com, where you can find a lot of information about how to deploy Vault and how to configure that. So I highly recommend you check it out. Then when you have Vault deployed, you need to harden it. This is where you store your crown jewels, right? So you want that as tight as possible, which means you want to do TLS termination in Vault. And by this, I mean, if you have some kind of load balancer running in front of Vault and you terminate TLS on the load balancer, then the traffic from load balancer goes to Vault unencrypted. It's obvious, but not for everyone. So I just think it's important to emphasize that. And you see the storage, you make sure that the storage is encrypted, you have ACLs in place, you have a local encryption, you have local telemetry, you have audit, you have MFA delete on the archive buckets if you're using buckets. You might want to synchronize the audit files to a separate region. So if someone gets into your current region where you run Vault, they can, or like on a separate account even. So then it's just, you're just streaming the audit files to the black hole where there is no access from this account. And in that sense, you make sure that you have your audit files preserved no matter what. Maybe blocking out SSH, have intrusion detection, backup and disaster recovery, a lot of stuff. I mean, jobs of system administrators is not easy. And a lot of this stuff is quite often hidden from developers. But yeah, there are a lot of things to consider. And look at down below, there is a link to the learn-hashicorp.com, where you will find a production hardening guidelines from HashiCorp, which is handy. So this is actual learning. I do recommend splitting Vault deployment infrastructure and Vault configuration infrastructure specific Terraform specifications into separate pieces and deploying them separately. And in order to understand what I mean here, think of Vault deployment specification as something where you would use your cloud provider for Terraform and stuff like that to provision the basic infrastructure, the virtual machines, the load balancers, DNS names, all of that. And Vault configuration Terraform spec is where you use Vault Terraform provider. This is where you use Vault API to configure it via Terraform. And the reason for this recommendation is if you do rolling updates or if you just running the jobs to update Vault, it might happen so that if you do it together, your load balancer might not be available or machines are rolling and the Terraform will get 404 or 403 or something like that when it's trying to access Vault API itself, and your deployment will get stuck in the middle. So you might not finish rotating the machines, like, you know, you are in a no man's land and you need to figure out how to go back to the previous state to repeat the procedure, which might not be easy. So it might cause yourself some downtime. And that's why I actually recommend rotating the infrastructure for Vault separately and reapplying the configuration for Vault itself separately. And it's a good idea to rerun your Terraform spec weekly just to see if there is any difference. You might apply automatically, or you might run plan and then have detailed exit codes so it fails if there are differences. So that will allow you to spot the configuration drift that might need your attention. So now Vault is up and running. What is next? What are you going to do next, right? You have to start configuring that. And to do that, you will need to have a Vault other environment variable set up, which points to your Vault. And you will need to have a Vault token. When you initialize a Vault, it will give you the 5 keys by default that you will need to unseal it and create a master key. But it also will give you a root token. And that's like a God mode. You could do whatever you like with that. And you will need this one for initial provision. And the good idea is to revoke the root token. So, you know, it's hard to steal something from you, something that you don't have. And you can always recreate root token using those 5 initial keys. Plus, you need to have a good idea what you're after. So that's one slide that I use to introduce people into Vault. And on the left, you have authentication methods. So you need those methods to get a token. You're using some kind of user directory to come into Vault and exchange user credentials into Vault token. Depending on what it is, the Vault token will get a certain Vault policy attached that will allow you to use a secret engine to get temporary credentials, which are called leases. Plus, there are a number of secret engines that allow you to work with static credentials, like a key-v, for instance. It's, as it is, key-value store that allows you to just store key-value pairs, such that you cannot generate dynamically. For instance, your SSL certificate that you're getting from your SSL certificate provider, or some kind of credential that you might receive from your integration partner, right? Stuff like that. This is how a token might look like. You might notice creation time and creation details. So for instance, that particular token is valid for 24 hours, which means that, and you see it has 20 hours to live, and that's handy, which means that even if this token being stolen, it has a very limited opportunity window for people to exploit it. So now auth methods and policies. It's boring, hard, but it is important because it allows you to get the token and stop using the root tokens, which is important. Don't use the root tokens. Right, so let's dive in. You probably will need more than one auth methods. On the right, you could see the snippet of the available ones, and the list is growing. So you might need one for machines, you might need some for CI/CD for bots, you might need some for apps, and where possible, use MFA for humans. So the way it works, you get auth engine, auth backend, and you have some kind of roles that match your credentials to the token, and then you get the token with a policy. And I'm using LDAP as example. So with the LDAP, what's nice, it's quite widely used, and it delegates credentials validation to a known directory. It's mostly used by humans, and it's always a good idea to simplify in procedure for your users, because you don't really want your users to call Vault API from command line to get the token, so you might want to write a small tool to simplify that. This is how you configure it through Terraform. As you might notice, it's written in Terraform 11, 0.11. Someday I'm gonna update the slides, but it's not a biggie. If you are to use those, you can run Terraform 12, and then there is a subcommand 0.12 upgrade that will make it Terraform 12 syntax, so not a biggie really. And if you ever configured LDAP for any type of application, this will be familiar for you. Important part here is pass your bind password as a variable, so you don't save it in your version control. Or look it up from Vault or some other place. Then you have LDAP role, which is called actually backend group resource, and you see everyone who comes in and is member of the DBA LDAP group will get DBA policy attached to their token. You don't really have to call them the same, but it's much easier if they are for people they don't really need to understand all those instances. So it's much easier for them to see all right, I'm a member of DBA group and then I get DBA policy. And you define the policies this way, and a little bit about the policies. You will need to have a policy to manage policies. So you have to have a way to provision yourself a token with some kind of admin privileges that allows you to modify policies. The policies are denying things by default, so you have to explicitly allow. And you don't have to, as I said, you don't have to merge the group name, but it makes things much easier. And members of multiple groups, they get multiple policies, which is also handy. Things to consider, you might want to set a bounds either. So you tell Vault only give a token to people who come from those networks. You set the token TTL, how long this token will live. You can always renew the token, renewing its TTL, but you can also set the max TTL just to have imposing a hard border for how long that token will be valid. So uprole, if you really have to, if you don't have a better way, for instance, if you're running CI, which is SaaS, right? So like Circle CI and stuff like that, that doesn't have access to your infrastructure and doesn't have access to better ways to authenticate itself, you will have to provide, and the uprole is basically login and password. And you have initial secret issue here. You need to provide it to the CI and hard code it there, and you don't really have a good way of auditing access because it's a static username and password, so anyone can use it. This is how you create it. You create a backend, then you create a backend role. So you define the role name, and this role name will get those token policies, right? And then you basically use CLI to get a secret ID and a role ID. Role ID is a login and a secret ID is your password. You don't have to do that through CLI. You could do that through Terraform using those resources and then store them in Vault. So you can then pick them up from Vault. And as you can see, I am creating the secret engine here already. So I'm piecing things together. I'm creating the auth engine, auth backend, creating the secret and storing them in KV secret engine. About the better ways is Cloud AM, Kubernetes, and there are much more. They're much better, especially when it comes to authenticating your machines. Like for instance, if you're running the on-prem workers, then in case of AWS and I believe other cloud providers, you can use IAM role to tell Vault, well, authenticate me because I'm using this role, and then Vault will go and check with AWS, yes, that's a valid role, and give you a token. The same as Kubernetes. You can exchange Kubernetes system account token to the Vault token, and that's very valuable for applications. I have another talk about how you can integrate HashiCorp Vault and Kubernetes apps, and since that talk, HashiCorp actually introduced a new solution that you might look up for. It's a mutating webhook for Kubernetes that injects Vault agents into your applications. I'm describing the similar way of doing things there, but it was recorded before HashiCorp released that solution. So I would recommend looking up HashiCorp solution first, and then if you want more details, check my talk. So now you have a token. What's next? You can start working with the secret engines. So you can get dynamic secret or static from KV. All those secrets will have a limited lifetime, which is perfect. It prevents a sharing, and you have an audit and a break loss procedures. We discussed it before. So KV is like, as we discussed it, it's a key value store where you store your static secrets that you cannot generate. And I do recommend having a multiple of them. So you might want something as a human-initiated secret storage, something that people can use to come and put secrets there. And people are usually messy, they don't follow structures, and you want to have a place for them just to put things in there in the way they like it to be. And then you can have machine-readable KVs, and then you have a Terraform spec that reads from the human-initiated one. You could use data to pick up resources from there, and then reads it in a strict structure to the place from where a machine is going to read it. In this way, you always make sure that the place that machine read it from, like your application, is always up to date. It has a strict structure. No one changed anything there by hand, and so on and so on. So it's a good way to separate humans and machines. And it also allows you to do more of infrastructure as code. Plus, it also allows you to check that all your dependencies are in place when you deploy into the new environment, because Vault will try to read those human-initiated secrets, and if they're not there, it will not be able to generate the KV for applications to read. It will fail, and you will know that you need to update Vault. It's much worse when your application is already deployed. It's trying to read the secret is not there. You have a downtime. So just a convention that might be useful for someone. And here we are setting up AWS secret engine. And for that, we will need to have AWS users that basically user credentials, actually, the key pairs that Vault can use to provision a temporary credentials for us. And here you can see we're creating the user, we're creating the access key, and we are having the policy for users that allows creation of the temporary credentials. So that's how you can see the documentation right here. That's a type of policies you will need for that. Now we're creating a secret backend. This is what you use to generate secret temporary secrets. And as you can see, we define the region. We are passing the access and secret keys that Vault is going to be using for provisioning. We could also define the default TTL and max TTL. And here we're defining the role that will be attached to the temporary credentials. And as you can see down there, we have Vault, AWS secret backend role. And here we say that everyone who would read this role will get the admin policy attached to that credentials. And here the type of credentials is assumed role. So we're going to get STS credentials with a secret token. Or we could also have a user, and that Vault will create a user and return us a key pair. And those are just the rest of the configuration. And this is how it works. You say Vault, write, AWS, STS, deploy, and you get access key, secret key, and secret token. In case of another credential type is a user credential type, you will just get secret key and access key. And you see this one is valid for 60 minutes. You can renew if you want. It says lease is renewable, but it's super useful since then you don't have to store your static keys on your machine. Every day you come to work, you want to do something, you get yourself a temporary credentials, and you start doing whatever you was after. And you are not really scared about those being stolen because TTL is super short. And even if it's being stolen, it's quite hard to exploit it. You could use temporary credentials to generate sign-in into AWS console URL, and this way you don't need SSO at all for AWS, and configuring SSO for AWS is a pain in the back. So check out this link. You might want to write a little bit of automation. As described in this talk, I highly recommend it. This one is from HashiCorp 2019, and here they share a lot of small toolings they built around Vault, and you could use that for inspiration. I highly recommend this presentation. Then database credentials. In my experience, people actually mostly start with Vault because they want to have the dynamic credential for their databases, since most of the, for instance, public cloud providers, they provide some kind of way of getting the temporary credentials already. And this one is hard because you have to provide, I don't have a Terraform example here because I'm kind of limited for this presentation for only half an hour or so. So you'll have to go tweak through this one. Creation and revocation statements. You have to provide Terraform Vault with those because you're basically giving Vault root password to your database, and then every time you ask for the temporary credential, Vault will log into your database, provision the new user using creation and revocation statements that you provided, and return those credentials to you. If not done right, Vault won't be able to revoke those credentials. For instance, if your application is using your temporary credentials to create a table, then you have to transfer table ownership to someone else, because when Vault is trying to revoke that user, when it's trying to delete that user, you're getting a problem. Since user owns the resources and you have to do something about that before you can delete it. The workaround here could be just to say no login, so no one can log in with that user. But in the end, you're getting a little bit of mess in your database, since different tables being owned by different users might be complicated. Another workaround that you can apply here is you can have conventions that your migrations, when you run them, say automatically create a no login user, like with your first migration, and then every time you create something new, you transfer ownership of that table or whatever you create to that user. In that way, your credential that currently used, they don't assume ownership of anything, and then can be safely revoked. Another thing that you could do, which I also recommend, is separation of deployment of your application and your migration. In that way, it's much easier to keep backward compatibility between your app and migration, so you can do canary deployment and stuff like that. But that's a topic for a separate talk. Also, you could consider using RDS IAMOS. Where possible, it kind of allows you to use static login and generate the passwords on the fly, which solves the problem of static password, but you don't really have an audit for this because it doesn't surface in CloudTrail in AWS. So yeah, maybe not so good for the compliance purposes. I asked AWS when it's going to be. They said it's on the backlog, but they don't really have any ETA for that. So SSH OTP, great stuff to use because then you don't really need to manage SSH key, and Vault will just generate a one-time password for you. Amazing stuff, works as a clock. You need to deploy the Vault helper, and there is an article on learn.hashicorp.com about how to go about this. There is a little bit of problem with load balancer because when you provision OTP, you need to give an IP address of the host where you want to be, and it might be a little bit hard to resolve if you are behind load balancer. So you might be requesting for the wrong host. Just keep that in mind. Secret rotation. Vault have API for rotating database passwords. So then only Vault knows root database passwords, which is great. You could still go, for instance, in case of AWS, into RDS console and provision your root password if something happens to Vault. So there is always the plan B, and this snippet allows you to rotate the database passwords, or you can use Terraform, as I use it here, for generating new keys and rotating the keys that I'm using in for the Vault secret engine, for instance. You can do the same with database, and then Terraform will not conflict with Vault as much because only Vault knows the root password, and the root password you use for provisioning of the initial database is different now, so Terraform might get confused. In that sense, you might want to generate the temporary password using Terraform random string and then just type it all the time and rotate it through the Terraform. But make sure that you secure your Terraform state storage because then your secrets are in Terraform. It's very important. Final thoughts. Vault introduction is a journey. It's taking quite a long time. It's a new paradigm of thinking, which might take time for developers and administrators to get into. It's a great foundation for building security platform, and it's better to have it earlier than later, I would say, because then you need to redo less things. And doing it as code is the most safe way and allows you a much more flexibility and speed when you have to investigate intrusions, if you have to, hopefully not. There are still some glue needed here and there, but HashiCorp improving Terraform support significantly. You should reuse and share as much as you can. Well, not should, but I urge you and I encourage you to share and reuse as much as you can, because the more we do so, the more secure we are, the better service we provide to our organizations. It's not a fun thing to be hacked. It's not the fun thing to have your public or your private information leaked in a data breach. So let's work together to make internet a safer place. And again, there is a need for best practices, right? So the more we share, the more we talk about that, the better we get, the more best practice we identify. So keep talking, keep sharing, keep learning. And that's all for me. I will be answering questions right after this session. If you want to hear more from me, you can find my credentials on the left. The Twitter, the email at 5XL. Check out the 5XL website itself, also my personal website. And if you want to connect, I'm accepting connections on LinkedIn. Thank you for your attention and have a great day. Bye.